Hi guys, my name is Lanny Dean and I'm a professional storm chaser. I've been chasing severe weather and tornadoes for 27 years. 26 to be exact, 27 this season. I'm the owner of Extreme Chase Tours and Storm Chasing Vacations. And I wanted to kind of go over some things today real quick about RadarScope. I know there have been a lot of questions on the Facebook page and a lot of questions in general from the general public about RadarScope itself. Now, I just kind of wanted to briefly mention that over the years, I've used a lot of radar application software, hardware, the whole 9 yards. Everything from GR Level 2, GR Level 3, which is a Gibson Ridge product, wonderful product I might add, to Storm Lab, just a number of products, guys, to be quite honest with you. And I think, to be frank with you, I use RadarScope exclusively nowadays and have since almost its inception. Now, today's video is nothing more than RadarScope 101, the basics of RadarScope. And I'm going to kind of go over some of the features, but more importantly, what I'm going to do in this video is show you how I have intercepted tornadoes and severe weather by using RadarScope. RadarScope is a wonderful tool that allows you to see severe weather, velocity returns, how hard the rain is, so to speak, things of this nature. It allows you to see the National Weather Service products right on your phone, right here, right on your smartphone. So today we're going to be using my iPhone. I do have it on my iPhones, my iPad, and now some of you, and on an Android, admittedly, some of you may have an Android product out there, and you're using that Android product, and that's perfect, no problem. But I'm going to do this today with the hopes that Steve Miller, my good friend Steve Miller over at WDT, and the folks at WDT actually see this video and recognize the quality that it could lead, or that it has, and what it can lead to. So with that said, without further ado, and you guys are going to see some tornado video where actually RadarScope, I want to make sure you guys understand that, where RadarScope is actually used, and I showcase it as the tornado either happens or is happening ongoing. So with that said, without further ado, let's get right into it. Now, if you're like me, you actually have maybe some radar applications on your phone already set up in a folder or whatever the case might be. But in this case, I have RadarScope right here, as you guys can tell. And we're going to open the product up. And obviously where you're at, and you can make these selections and make the changes, but where you're at kind of depends on what comes up first, if you will. And again, you can make those selections and make those changes. But for today's example and today's use, guys, we're looking at a Denver here, DIA. So I can just click this button right down here, if you will, and that's going to, what that's going to do, and I say button, we'll call it a soft button. That's selecting my NOAA radar sites around the country, if you will. In other words, we've got, if I zoom in here, we've got Dodge City, DDC, KDDC. We've got Vance, if you can see that real clear. There's KICT, which is Wichita. Some of you folks may not understand some of the naming conventions. But that's okay. We'll learn that. And in maybe one of these videos, the next video or what have you, we'll go over some of this stuff. There's Goodland, KGLD, and of course, Pueblo, KPUX, and then Denver. And because I'm close to Denver, we're going to look at some of this here in Denver. As you can tell, it's raining southeast of Denver. So what I'm going to do, guys, is just to let you know, the reflectivity mode is what I'm looking at right now. And this reflectivity mode is nothing more than how hard the rain is coming down, if you will. In other words, the strength of the rain. And this is in layman's terms. This is nothing meant for scientific type use, if you will. This is just for the prosumer, not necessarily for the the professional necessarily, but the prosumer, the consumer, and the prosumer. But in any case, we can zoom in on this, very easy to use. We can zoom in on this. And I've noticed some people saying, oh, wow, there's a little hook. There's a little whatever. Is this why isn't this warned, or whatever the case might be? Well, my good friend David Moran actually wrote a little blog article about velocity structure and whatnot, and I would encourage you to check that out. WDT linked that, I believe, and it is on the internet, so it's very easy to find. But I wanted to show you this as well. This is not a hook, guys. It's rain, heavy rain. And what we can do here is, since we're in the super res reflectivity tilt 1, which is 0.5 degrees, that means it's the lowest elevation angle that the dish is at. When I say dish, I'm referring to the dual polarization WSR-88D, the main weather surveillance radar dish from the National Weather Service. Now, if we click this again, or unclick it as well, it's going to show us towns, cities, whatnot. All right. Now, it looks like the town of Haswell, if you guys can see that very clearly, is getting some pretty good rain right now. So, with that said, what I'm going to do here real quick is, I see that these storms are way to the southeast of me. So I'm going to change radar sites just because I want to get a little closer. KUPX, as you guys can see, is a little closer. So we're going to tap on KUPX. Now we can see the storm tracks. And now we can actually see the icons, the storm icons, the cell icons, or cell information, what we call cell information. And we see that there's 3 or 4 or 5 of them here. And there's even an outflow boundary, it looks like, maybe a cool front or an outflow boundary, some sort of a boundary. But if we zoom in, and this is meant to kind of teach you guys a little bit, but if we zoom in and we actually click on one of these icons, if you will, it's going to give us, if I can get it to click here real quick, my phone, the face of my phone is dirty. It's going to give us a little bit of information about that particular cell. There we go. Sorry that took so long, guys. The face of my phone is a little bit dirty, so I would encourage you to keep the face of your phone clean. But you can see that says cell C3, 8:40 p.m. The hail size that it's estimating is 0.75 inch. That's possible. Doesn't mean it's happening, and certainly there are no spotter reports to reflect otherwise. Now, RadarScope has a bunch of features that you can turn on and off to showcase spotters, where they're at, what they're seeing, the reports. You can send reports. You can send the MPing reports. You can also send, as I said, spotter network reports. But all you have to do for that is to click on that little cell icon. And once you click on that little cell icon, it's going to show up. You can do it anywhere where there's a cell icon. There's cell F2, and it's listed, and it gives a little bit of information on it. Okay, well, the hail size is roughly ½ inch, or could be ½ inch at this time. And again, radar is kind of a funny thing in that it is not an absolute necessarily. What it's saying by the hail size is we're saying, hey, this could have hail in it at XYZ. So that's what makes RadarScope a wonderful tool. Now, this looks like an interesting feature to me. And I've seen some folks on the Facebook page go, okay, great, this is a hook, this is blah, blah, blah. Well, hey, I'll tell you what, let's check it out real quick. So I clicked right down there at the bottom, and just let me do it again, just so you guys know. Right down here. Now, this is with an iPhone or an iPad, whatever. You can same thing. From storm relative reflectivity, high-res reflectivity, we're going to scroll down and go to storm res reflectivity. This is super res reflectivity. And we're going to see. Okay? So what we're looking at now is which way the winds are blowing mode. That is the layman's term for storm relative velocity, which way the winds are blowing. I don't care if it's high res or whatever. That's really what this product is showing you is, okay, the radar is estimating the winds blowing towards the radar or away from the radar, and how fast it is anticipating those particular winds to be blowing. Now, in this particular case, since we're in Pueblo, the green is moving towards the radar, and the red is moving away from the radar site. Now, as you can tell, let me zoom in, there's no real couplet there, what we would consider a couplet. Now, I do see a little bit of, some reds and greens together, but if you were to see a true tornadic storm, you're going to see these reds and greens and maybe some purples in there, depending on if there's any de-alias data, whatnot. Oh, just updated. So you can actually see now that that's gone, right? So you're going to see those colors come and go, kind of change and whatnot. But as far as a prosumer and consumer viewing point and standard to look at, these particular colors represent nothing more than which way the wind is blowing and how hard the radar is estimating that as. So with that said, what we've done is we've gone over storm relative reflectivity and storm relative velocity. I apologize. In any case, guys, this right here, you have all these features, and we will talk about all these features from correlation coefficient all the way to the hybrid scan hydrometer classification. That is, we'll get into that. We'll get into those specifics, but this is a wonderful, wonderful tool, and it's something that I use actually on the tours and actually out when I'm storm chasing by myself. I use my phone and my iPad. No longer do I have to carry a huge laptop and the whole 9 yards just to be able to chase and just to be able to give my clients and whatnot severe weather. This is the product. This is our main product. This is what we use. So if you have not done so, I would encourage you to look at and purchase the RadarScope. It is $9.99, 1 year subscription. Of course, they have different tiers. You can go to the Pro tier and whatnot. But this is some of the stuff that we utilize while we're actually out chasing. Now, I'm going to show you guys some video. I'm going to show you guys, kind of pan to some video here, if you will, and integrate it with RadarScope and actually show you RadarScope in action when a tornado is forming and or some of the chases that I'm on while I'm using RadarScope. I actually show it in the video. So anyways, that's just a brief overview, RadarScope 101, and that kind of gives you a little bit of an idea. But again, I would encourage you to purchase this. It is a wonderful tool, whether you're an emergency management folk, whether you are in that type of a role, local volunteer firefighter, whatever the case might be, whether you're a storm chaser, a new storm chaser, and you're looking at a program that you need to assist while you're out in the field. This is the product that beats all products. And guys, I've used all products from GR Level 3, as I mentioned earlier, to Storm Lab, GR Level 2, GRAE. Now that's meant kind of for a scientific purpose, different purpose. But as far as the prosumer and the consumer, as well as even the professional who uses this on air, the meteorologist, folks, this is it. This is as good as it gets right here. So with that said, let me, and I want to touch base one other thing real quick. If you click the 17 up here, this number, you guys can see this. This is going to give me my warnings, my warning attributes. So I can scroll these warnings and then select each warning. These are all flash flood warnings that I see thus far, and they are. And we're just going to click this bottom, this top one since it's fairly new, and this is a flash flood warning, right? And you can see the flash flood box right there, the green box, what we call a flash flood warning box, and we're going to click on it. flash flood warning, expires blah, blah, blah. Then you can click the little info button, and it's going to give you the entire info. What the National Weather Service product text says, right? It's going to go down. It's just going to tell you. National Weather Service in Tucson has issued a flash flood warning for west central Conchonese County in southeast Arizona until 8:15 p.m. Mountain Standard Time. All right, and then it's going to go further on down and kind of explain, elaborate things to you. All right, guys, that's the thing. Why I mentioned that is because for the prosumer and the consumer, that's a wonderful tool for you to have, just so you guys can see the warnings. It's unbelievable that you guys can see the warnings. Now, we're not going to get into the hail tracks and all that good stuff and the tier levels yet. This is just kind of RadarScope 101, meteorology 101 via RadarScope. And guys, wonderful tool, wonderful product. Without further ado, let me go ahead and transition into some of the video where I'm actually using it in the field, and you're going to see the tornadoes that have developed in front of us or that we're on, and the chases that we've been on utilizing this particular product. In this particular video, we're going to focus on the May 16th, 2017 tornado outbreak that occurred across western Oklahoma and far eastern Texas. That would be the McLean, Texas area tornadoes, and of course the Carter and Elk City tornadoes. And as you can see, we utilized RadarScope to its fullest extent, and obviously we filmed Tornado Genesis with the aid and addition of RadarScope. All right, folks, we're coming through Wheeler, Texas, and still got a tornado warning. It's headed directly towards McLean and then right towards Wheeler, as you can see. It is a monster of a storm, so we're actually just trying to wait on it. I say wait. We're going to go over here to Wheeler, right here in Wheeler, and drop south towards Shamrock, kind of get a bird's eye view if we can. We're coming through Wheeler right now, and then we'll be going through Shamrock. There's another cell down south of us, due south of us, that actually looks like it's getting its act together as well. It's right there. There's a big daddy right here. Tornado warned. Fully condensed tornado. Tornado. Fully condensed tornado right there. Fully condensed tornado. There it is. Got a tube right here. Over by McLean. Tornado. Alright, we're trying to drive between two tornadic cells right here in 40. We're cutting the front flank here a little bit. It's the best we can do. I can't quite speed it up enough. Looks like the strongest hail was back there, so that's all I can do. If I can get over to Sayre, we'll be alright. But I don't know that I can. So we're going to do the best we can. Tornado warning. All right. All right. We've moved here. You guys can tell this thing is right there. We're looking at it right there, if you guys see. Gosh dang, what a tornado. It produced a big tornado.
Alright, as you guys can tell, you can see the circulation right here. We are right here just south of it. Somebody's, yep, tornado. Tornado, the report, okay, tornado.
What is that? Yep, that's what I thought. There it is. There's a tornado right there in the field. What's that? I know it. You see, you get that tornado? You getting it? Tornado right there. Wow. Yes. Trying to hold the camera. Sorry, guys. Yeah, tornado right there. I'm gonna come back to your vehicle here so I can hold my camera. I don't mess with the tripod. Yep. Tornado. Excellent. It's a big circulation, actually. All right. I believe we got a large tornado here. Right up here. Right on the, see the whale's mouth right here. And it went across. You guys saw the video. This might be some anticyclonic stuff here, but that's the RFD punching around right in here. And the hail and rain has wrapped around, completely around the circulation. It's back to the north of us now.